Recording starting. Okay, great. And let me just post the attendance register link. Hopefully it works. If you go onto it as well. Okay, cool. So tonight we're starting with probability. We've now in the previous 3 weeks we've looked at the beginning of a work that looked at variables, how you look at the variables, if it is in a table format, if it is looking at graphical format, and then some summary things around that. Now we're moving into probability, and nearly for the next few weeks we will look at different forms of probability. So tonight we start off with just the principles behind probability. Then we will go into different distributions of probabilities. Okay, so basically the first thing when we talk about probability is nearly, and we get to some of the definitions in a while as well that you will have, because yeah, and then we'll get into examples. But what probability basically is, it is telling you the chances of something happening. So it is looking at events and what is the possibility for something in that event to happen. So when something is very unlikely to occur, it is closer to zero. When it is more likely to occur, it is closer to one. What also happens is when you can also put the probability in a percentage. And if you look at a very simple example of that is when they forecast weather and they say the chances of rain or something like that. So there they've just used the probability into an percentage or a percentage. So we're looking at probability of 0 to 1, from less likely to more likely to happen. But the other thing that you will see in this chapter is the ways they talk about two other things, how you can measure some type of probability. So the one is looking at combinations. So again, when we look at assignment 2, they will probably, now that we are in probabilities, they will give you a problem around combination, or they will give you a problem around permutation. So again, very important that you just look at the two concepts. We will cover it in today's session. If not in today's session, we will definitely cover it when we prepare for assignment 2 in any case. So then I will make sure that we have a question on the combination question and on permutations. Again, when you work it out, there's on your calculators, there's a sign that will show you how to, or there's a, and on my HP, there's one that gives you the NPR, and there's one that also shows you NCR. So it is written sometimes differently. So I can now see on my, it written sometimes as that, so that they talk about the combination. Sometimes it is written as that. So in both instances, all that you would need to put into your calculator is the sample that they give you, and how many times it will happen, or how many combinations you are looking for, or how many permutations you want to combine. When you look at the mathematical formula, there's a slight difference in the one for combination. So you will see where the difference comes in is both have the n factorial and the n minus in brackets factorial, but in your combination there's a extra n factorial that comes into place. So by dividing that number, or that what you will get by that n factorial, means that your combinations will always be less than your permutations. Okay, so again, something to just keep a back of your head when you are doing the assignment and when you're looking at questions around it, because again, they might, and most likely, in a set of questions, they will most likely give you the answer for permutation and the answer to a combination as the answers to a set of questions. So again, we just need to be careful about that when we look at it. Then we just look at a few of definitions, different ways also of writing the probabilities in formulas. So I think that's also important, because again, if you look at your textbook, it might look different to your study guide. When you maybe want to Google something on probabilities, it might also look different when you're looking at the formula. So I will show you a few differences now. But again, if I want to ask you something around probabilities and the theory around it, it will basically be slides nearly 7 to 18 that one can look at combinations. But I also did a summary slide. looks rough at the moment, but it will make sense when we get there, in slide 19 as well. So again, when we look at it, event is a collection of sample points. The probability of any event is equal to the sum of the probabilities of the sample points. So what that means is, again, if you just look at the definitions, and the previous slide that I also showed. So if you get a probability of X that they ask you, always remember that probability is also from 0 to 1, including 0, including 1. So when they give you a probability that is negative, it's something that you can't have. If they give you a probability that's more than 1, it's a probability you can't have. If you work out, and we get to that now, where you look at different probabilities, and you get more than 1, it's not something that is possible. So important, nearly probability always be from 0 to 1, and including the 0 and the 1. What we then also get in the literature and in your study guide, and very important, is for you to know it, because they will use these words into your questions. So they will ask in a question, they will say the complement of an event is equal to. So you would need to know then what do you do with it. If I say something is mutually exclusive, what do you do with it? So the easiest way to explain what the complement is, so if you have probability of A of something happening, the complement is that it will not happen. So it is 1 minus the probability of that. In the literature and in your textbooks, they do sometimes, they write it differently. So sometimes that is the sign of a complement. Sometimes they write it as with a C to say, well, it's a complement. And sometimes they write it just with, what do you call it? That nearly a apostrophe or whatever, that small signage. So there's, again, different books write it differently. In your study guide, I think they like this one, but sometimes they use the complement as well. So again, it happens to be shown differently, but what it means is, if the probability of event A was 0.6, the probability of the non-event happening is 1 minus 0.6, which will give us 0.4. Okay, so and a simple example is, let's say the probability that the Stormers will win this weekend for rugby is, let's say, 75%. Then the probability that they will not win it is 25%. Okay, so that is nearly how it can be seen in a practical way. So if you think about it, the probability that somebody will win the lotto, they say, is 1 out of 14 million. So the probability that you're not winning the lotto is 13.9999999 million that you're not going to win it. So again, if you want to play the odds, which we can also call probability, that's just another example. Okay, then we look at two events. They talk about sometimes the union of two events, but basically it is event A and event B happening. So normally, and we'll probably get to that. So the union of of two events happening, the part in the middle of that we call the intersection. So the easiest to nearly explain it is that, so let's say event A is that I have numbers 1, 3, 5, and 7. Event B is that I have numbers 4, 5, and 6. So the intersection in the middle is the one that is sitting in both events, which will be 5. So if I look at two events that might happen, that is what the intersection means. Okay, we can sometimes call that intersection is also, here we denote it by that sign, but we can also just say what is the probability where it is A and B. Okay, so the two things that we can talk about is and mostly in this, what we will use is the and. So basically where both A and B will happen. So in the exam as well, they will more likely use the wording than actually using this notation. But again, just so that you have both and have a view on both, because also when we look at this, the textbook, they like to use this notation in the textbook as well. So the addition law is actually then, what is the probability of A or B? So nearly now we can see, so that sign means and that sign means or, if we're looking at the definition. So what's the probability of A or B? It is then the probability of A plus the probability of B minus the probability of the and. We'll get into some exercises now around it, but I thought it's just important to just show some of the ways that it is written. Okay, mutually exclusive events is when there is no intersection. So basically that intersection that we had in the previous one, if there is no intersection, that is just equal to 0. Okay, so again, important because they might in a question say events A and B are mutually exclusive. Here's the probability of A and here's the probability of B. Work out what is the probability of A or B. Then you need to know that the AND component will be equal to 0 in your formula. So that's just, again, when we talk mutually exclusive events. So that component of the AND is basically 0. Then there is conditional events or conditional probability that also happens. Sorry, so in conditional probability, we will always say A given B or B given A. So you will see that in examples where they will tell you your mark for this subject is A, your marks for other subjects. So then they will ask you a question about what's the probability that you got for the one a specific mark, given that you will also doing something else. So that is nearly how one can look at it. The permutation for that is how we write it is probability A given B, and that formula, another way just to write it is then the probability of A and B divided by the probability of B. How I also see it and try to remember it is that whatever is in the end of this formula is also the one that I'm going to divide by. So if it was probability of B and A, I would have divided it by probability of A. So again, depending on how it ends, that is how the value or what I am going to divide it by. Again, just an example. So we'll get to a question around conditional probability as well tonight. That one I'll rather show in the other slide. Independent in events. Also important just to look at this. So if a probability of event A is not changed by the existence of event B, we would say that events A and B are independent. So when something happens and it's not because of something else that happened, that is when it is independent. Again, important to know independent because, oh, I haven't added it there. I added it in here. So how, if two events is independent, we can work out the probability of A and B by multiplying probability of one event times the probability of the other event. Again, important because they can again in a question say to you, you've got two events that are independent, calculate the probability of A or B, and then just give you the two events, what the probability is. So then you need to know, because they said it's independent, how to work out the AND. Okay, so, but the two things I think it's most important nearly is the mutually exclusive and then the independent events, because that is the two that they really use a lot in questions. Um, so let's get to a few of them. Um, so in this, okay, I added this here because that if I look at some of the options, we will need to look at that formula. Um, so again, when you writing the exam and that, or even the assignments, you have all your assignments. You're allowed to have all your formulas and things like that. Um, what I now remember is I will send you some of my summary documents on our WhatsApp group so that you can have it. It's normally a one page and nearly of a study unit. So I will send that to you. If you're not on the WhatsApp group yet, please send me a WhatsApp on 0837908387. I'll add you to the group so that I can just again send you some of those documentation. Okay, so this is an example of how they can ask you probability questions. Um, Another one is when they give you data. So that again, we need to look at data and then work out the probability. Other way is if you need to work out certain probabilities that they give you the probability of a one, give you the probability of the other one, and then you need to apply some of the rules. Definitions as well. So you would see that, where was it? Here, there is some definitions that they will definitely ask. Then they would ask something on independence. I think one of it was previously, there was also one on mutually exclusive. And through these, they test some of your other things that you need to know, like the given, like the and, like the or. So there is, in these few examples, nearly everything that you would need to know about probability. Okay, so let's look at this first question. Um, Interrupt me at any time when you have questions. Please ask when something is not clear. Okay, they give us this table, so let's just look at things in this table before we even go to what they're asking us. So we see here that we are looking at students that achieve a grade of A in marketing or they don't, with a combination of a A in statistics or not. So the probability of a cross tabulation of this will always be 1. So here they already have divided the number of students that's in each block by the total. So they already have done this for each of these cells. So again, this is nearly the second step in the probability that they have done already for you. So we know from this that there is 0.29% or 0.29 of students that are achieved a grade of A in marketing. There's 0.71 that did not. Again, if you achieved it and not achieved it, you can see it is 1 minus the other one. When on the other side, there is achieved a grade of A in stats and did not achieve an A in stats. And again, you can see how we can work out the complement if they ask it. Okay, so the first one that they ask is, what is the probability of the student achieve a grade A in marketing? So achieve grade A in marketing is 0.29. So that is correct. Again, we're looking for the incorrect one. So what's the chances or the probability that the student achieve a grade of A in stats? So A in stats is that one, which is again correct. So again, we're looking for the incorrect option. Okay, so now they're starting to ask different things. As you can see, it's not just a straightforward work this out. So event does not, it, so what is the probability? Probably, or let's just read, event does not achieve a grade A in marketing and does not achieve a grade A in statistics are mutually exclusive events. Okay, so look at that question. So event does not achieve a grade A in marketing, does not achieve a grade A in marketing, and does not achieve a grade A in statistics. That one. So if we cross those two, we can see how many students did not get an A in the one and also did not get an A in the other one. Okay, so are they mutually exclusive? What should that value be if they were mutually exclusive? Okay, so if they was mutually, great, Ian. If they were mutually exclusive, they should have been zero. It is definitely not zero, it's 0.58. So that one is the incorrect one. Okay, so if it is mutually exclusive, that value should have been zero. Okay, but let's look at the other two as well. Um, Events achieve a grade of A in marketing, and achieve a grade A in stats. Okay, so we're looking at that event. And then the question is that events independent? Ooh, okay, at least we know it should be. Okay, so how do we know if that um, is independent? So for it to be independent, the probability of, let's just get it, grade A of marketing, grade A. So it should be that I get a A in marketing and that I get a A in stats. So if I multiply those two together, I should be able then to get the same answer. So the probability of getting an A in marketing is 0.29. If I multiply it by the probability of A in stats, which is 0, 0.183, I should get 0.053 for it to be independent. So 0.29 times 0.183. Okay, so that answer is 0.053. 0.053. Okay, so because it is the same, I can say that the two events are independent. So nearly remember for independent independent events, two events where probability of A and B is where it is probability of A times probability of B. So that is what we did here. The probability of a one times the probability of the other one. And in this instance, it was equal to what they've given us. So it is independent. Okay, and then the last one is what's the probability that a student achieves a grade A in marketing, grade 8 in marketing, given that he or she does not. So grade A in marketing, given that she does not achieve a grade of A in stats. Okay, so if we look at this formula, they tell us the word given. So the probability of a one given the other one. So the probability that a student achieves a grade A in marketing. So let's do that, A grade in marketing, given that he or she does not achieve grade A in stats. So not stats. Let's just call it NS. Okay, so then it is the probability of a 2. So the probability of a and. So let's see what that is. The probability of a and is 0.237. And then that is divided by the probability of a not A in stats, which is 0.81. Sorry, 0.817. And hopefully when I divide those two by one another, we get 0.2901. So 0.237 divided by 0.817 gives us 0.2901. Okay, so, and again, that is then what they have said it should be. So in this question, they gave us all the information needed, but what they did not do is to say to us what is the formula for mutually exclusive. We should know it, or we can read it off a paper. Also on independent events, they nearly testing us if we know what independent events mean. And then also in the same question, they have asked us that we nearly look at the probability when one event is given. So they've tested in this nearly all the important things that we actually need to know. Ways and that one. So again, it's nearly just important that one remember what the definitions are, but how you can use it when in the table as well. So a lot of these questions will focus on those kind of things. Okay, so let's just make that right again. So in question 20, um, they give us words, so they tell us it is marketing, it is not marketing, it's stats, not stats. In this table, they just tell you you have event A and you have event B. Sometimes just by not saying anything else about it, it sometimes make it more difficult. It's sometimes much easier to understand if it is something that you can relate to nearly. Here it is just two events A and B. Okay. What they also don't give us is they don't give us any of the totals. So they didn't tell us that the total of event B1 is actually 0.7. The total of B2 is 0.3. If you add all of those in the boxes together, you will get 1. So that can also be a test just to make sure that you've done it correctly. The probability of A1 will be 0.6, and the probability of A2 is 0.4. Okay, so again, things that they haven't added to it, but you will probably need it somewhere in the calculation, or it might be even asked in a straightforward question like the first two. So what's the probability of A1 happening? We've added it's 0.6. It is correct. What's the probability of B1 happening? There we've added it's 0.7. It's correct. Okay, so now they're asking us a bit of different things. What is the probability of A1 and B1 happening? Okay, so where does the two intersect? At 0.4? So the probability of A1 and B1 happening is 0.4 is correct. Then the second one, what is the probability of A1 and A2? Sure. So can A1 and A2 happen at the same time? Okay, so A1 and A2 can't happen at the same time. So the probability of A1 and A2 should actually be 0. Okay, like in option 5, where B1 and B2 is equal to 0. So that's why it is nearly important or easier when there was something linked to that A1. So remember the previous one was got an A in marketing, did not get an A in marketing. So if you had that statements here, then it's easier to see that, okay, but what they're asking me is it possible that I could get a A in marketing and I could get not a A in marketing? No, it's not. So that is basically actually what they've asked here. If it was in the previous question, is what is the possibility or the probability that the one will happen and the other one, where if it is said to you, what's the probability of you getting an A for the subject and the probability that you will not get an A for the subject, that can't happen. So it should be 0. Like it was in the second, or option 5, what's the probability of getting an A for stats and the probability of not getting an A for stats, again, is 0. So sometimes some of these questions is easier when you can actually reference it to something, where it is sometimes a bit more confusing when they just give you the plain symbols. Then nearly try to add something to that to make it a bit simpler for you. What is the so you could have said, I've got green eyes and I don't have green eyes. So you can't have both of them. So either you have it or you don't. Um, so things like that, just to make it a bit simpler than purely the symbols that they use. What they also can do, and this definitely in the last 2 years have happened in assignments and in exam papers, is that they don't complete the total table. There is enough information in here that you can still work out what is needed. So they normally tell you then, okay, complete the missing numbers, but look at what they ask you. So complete the missing numbers in the above table and calculate what is the probability of A and C. So you need to work out what is the probability of that. Okay, so how I need to work that out is when what is to get that value, and then we will use nearly the formula in this instance. Then I also want to show you another way of doing it. Okay, so if we want to get the and, that is what we're going to look for is the and. So if we do a bit of manipulation with this, we can take that to that side. So a way to work it out is we've got the and, and we just say PA plus B minus the OR. Okay, so that is if we needed to do it with the formulas. So let's just write it out. But there's another way of doing it as well. So that is if we needed to do it with a formula. So other way to do it is when you look at just getting that number, we can just say, okay, well, what is that number that we need? So that number is 14. How did we calculate that number? We said, well, okay, that line needs to add to 45. So what plus 31 gives me 45? It is 14. Could have done the same from the other side, is to say, well, I've got 15 there. What must I add to 15 to get to 29? That is 14. And then all I do to work out that probability is to say, well, that probability of the and must be then the 14 divided by the total probability or the total sample. So what we actually did was to say that is x divided by n, and that will be equal to 0.2. Okay, so that would have given us option 5. So that's, with a table, a very quick way of getting to the answer, where if we said that we need to work it out with a formula, now suddenly we're like, okay, well, now I need to complete that as well. So that, sorry, is 25, not 35 that I wanted to say. Then we need to complete that. Okay, then we need to complete, just see what was that, because now suddenly, what was that, 51? Okay, so if that is when 51, that must be 41. So now it takes time. Now I need to work out what is that probability, what is that probability, what's the probability of the or, and then only do I get to the and, where if it is given to you in a table, you can basically just say that x value divided by n will give me that number. Again, saving you time. Okay. Then some definitions that we nearly have done in slide 19. You can basically, I think, use slide 19 as a very nice summary of everything that you need to know about this chapter. So which one of the followings is again incorrect? They love using the incorrect one. So again, out of your first assignment that you've done, is for 1610 first assignment open at least now, or not yet? I know 1510 was open, was done, finished. 1610, is it at least open or still not? But what you would have
It's
seen.
open.
Is it open? Okay.
Yeah.
Okay. But again, would be interesting to see how they have the questions around the how many was incorrect and how many was correct, kind of, because I think with that as well, what they like to do is nearly ask you a few of the same thing, and then suddenly throw in a opposite one. So just be again careful that there's not like 4 or 5 incorrect and then suddenly they throw incorrect, so that you're nearly still looking for the incorrect one. Incorrect, when it comes to definitions, is sometimes much more difficult, because what I've seen a lot is that there's some of them that are nearly very close to one another. So when you need to look for incorrect ones, sometimes it is more difficult in the definitions to get to the incorrect one. But let's go through them. The probability refers to a number between 0 and 1, which expresses the chance that event will occur. Yes. Okay, so a number between 0 and 1, and that the event will occur, that is correct. Option 2, an experiment is an activity of measurement that results in an outcome. Correct. They don't tell us what the outcome is. They just say there will be an outcome. So if you do experiment, the outcome will be true or false. They don't tell us what the outcome is. So again, correct. If the event of interest is A, the probability that A will not occur is the complement. Correct. So if it is, I got an A in stats, the other one is that I will not get an A in stats. So that is the complement. When events A and B are independent, you can work out the and by multiplying the probability of A times probability of B, and that is also correct. Okay, so the one that is incorrect is 5, and you can see it is probably a question that I should take out. This is a very old set of questions, but the sex of students, male and female, cannot be used as example of mutually exclusive events. So again, we probably now would have not have this one, and we would have said yes. Okay, so in this instance, it was still seen as mutually exclusive. So something that one can use in this place is something like, in which province were I sleeping last night? So you can't be in two provinces at the same time. So that would have been something that are mutually exclusive. Okay, definition question that tested mutually exclusivity, independence, complement, the 0 to 1, and then also nearly what is an experiment. They could have asked you what is the event. They could have asked you any of the other types of definitions in here, but nearly testing all of the things that is important. Okay, so now they give us again two events. Again, they don't tell us what it is. So they just tell us, okay, event A happens, this is the probability. Event B happens, this is the probability. And then they ask us a few questions around it. Okay, so if events A and B are mutually exclusive, then A or B is equal to 0,8. Okay, so let's look at it. If it is mutually exclusive, it should then just be the probability of A plus the probability of B. Okay, so it is 0.5 plus 0.3. So if it is mutually exclusive, that is correct. If events A and B are independent, then A or B will be 0,8. Again, let's see. If it is independent, all that we will add is minus the probability of A and B. I'm just going to write it as A and B. The A and B will be then, because it is independent, be 0,5 times 0,3, which gives me 0,15. So in this instance, 0,8 minus 0,15 would have actually then be 0,65. So that would then be incorrect. See, it's what this is also showing, and this is in this example, that you can't be mutually exclusive and independent, but it's not always like that. So just it doesn't mean it's always like that, but this in the example definitely the case. Okay, if events A and B are mutually exclusive, then the probability of A given B is equal to 0. Okay, so remember the formula is probability of A and B divided by the probability of the last one, the probability of B. So that would have been then probability of 0, because if it's mutually exclusive, the probability of A and B is 0. 0 divided by 0.3 will give you 0. Okay, so that is correct. Then the follow-up will probably be the independent one. So if events A and B are independent, probability of A given B is equal to 0, 0.5. So let's now see. So for A and B, we worked it out as 0, 0.15. When it's independent, we still divide by the probability of B, which is 0, 0.3, and then 0, 0.15 divided by 0, 0.3 will give us 0.5. Okay, so again, we can nearly see the difference when it was mutually exclusive, it's 0. When it's independent, it is 0, 0.5. Okay, so then the last one is, now they tell us if A and B is equal to 0, 0.2, then A or B is equal to 0, 0.6. Okay, so for this one, we would just use the normal formula that we have. So it's probability. Okay, sorry. So we can say probability A or B is equal to probability of A plus probability of B minus probability of B, probability of A and B. Okay, so we know that probability of A plus B was 0.8. They tell us that the AND is 0, 0.2. So 0, 0.8 minus 0, 0.2 is 0.6, which makes that one correct again. Okay, so in this, the focus was mainly on mutually exclusivity and independence. I haven't seen this in quite a while that they do it this way, because that was, in a sense, when you do option 1 and 2, that is very easy to nearly get to the answer that you're looking for. So I haven't seen that they do this in quite some time, where they give those two options together. They normally would give you more a given that you need to work out, more than have it straightforward like this. Okay, what they can also do is to tell you I've got two events, A and B, that are independent. And then they give it to you in a fraction. And please, when you get it in this format, automatically put it into a decimal. So 1/4 is 0.25 and 3/4 is 0.75, because else it is very difficult when you start working with fractions to work it out. I find it much easier with the decimals. Okay, so they tell us the two events are independent. So if the two events are independent, we know that the A and B, the probability of that should be equal to 0.25 times 0.75. So because it's independent, we can say this. Okay, so let's just look at what that will be. So 0.25 times 0.75, we get 0.1875. Interesting that it was not given as an option here. Then they ask us, well, we need to work out the value of A given B. So that is the probability of what we said. We work out the AND. So in this instance, it's the AND. And we divide it by the probability of the last one. So the probability of B, which is 0.75, which will then give us 0.25, which is actually the probability of A. Okay, so when something is independent, you need to work out the given. Your answer is basically the other probability. Let's quickly check if it is in this set. Else one must just maybe add it. Okay, so I will add it for you in this set of options. I know it is in the study guide, but so when two events are independent and you need to look at the given, you will basically, the answer will be the other probability. So if it's given B, the answer will be the probability of A. If it was given A, the probability then would have been, or the answer of that would have been your probability of B. Okay, so I will just add that formula to the original, because I think that is also important that you know that. Then the last one. So in the last one, they give you all of the numbers, they give you the total. Then they ask you to work out a few things. So they ask you to work out what's the probability of M. So what's the probability of the person being male? So that is just straightforward, supposed to be 115 divided by 200. So let's see if that is 150 divided by 200 is 0.575, which is correct. So that was just looking at the total of males dividing by the total sample. And again, how you can look at it is x divided by n. Okay, then they ask us the second one. Let's just see if there's anything easier. Okay, so let's do that one first. What's the probability of being male and have physics? So that is 25. So 25 divided by 200 supposed to give you that answer. So 25 divided by 200 is 0.125, which is correct. So again, we just took the x divided by n for that. Question 2, let's look at that now. So what's the probability of being male given that the person has physics? Okay, so what we can look at it from the point of, okay, what's the probability of the A and B? So male and physics, because that's what we're looking at, is it's 25 divided by 200. And what's the probability? Remember that we divide by the probability of the second one. So what's the probability of physics is 50 divided by 200. So if we then work that out, it must be 25 divided by 50, which will give me 1/2, which is a half. Okay, so that one was also correct, but again, we looked at the formula that it is the probability of M and P, and it should have been now. No, that is right, divided by the probability of P. Okay, so that is, if we looked at the formula, that is how it would have been. Probability of being male and having physics divided by the probability of physics. Okay, we can then look events M and P are not mutually exclusive. M and P, so M and P, if it was mutually exclusive, that would have been, should have been 0. So events A and P are not mutually exclusive, which is correct. So the incorrect one is this one, but let's look at it. What's the probability of C or F? Okay, so what's the probability that you study chemistry? So it's the probability of chemistry, which is 100 divided by 200, plus the probability of being female, which is 85 divided by 200. It's 85 divided by 200, minus the probability of C and F. So minus the probability of C and F, which is then 40. So 40 divided by 200. We could have said It's 100 plus 85 minus 40, so it's 145 divided by 200, which will probably give us 72.5. 145 divided by 200, yes, is equal to 0.725, which makes option 4 the incorrect one. Is there an easier way to do this one? Probably not. So if I look at this, or there's not really an easier way to do that. You need unfortunately to follow the steps with the formula. But there was easier ways to do all the others. So again, in the assignment that's time-based or the exam that's time-based, I would first go to the easier ones. That is, you can nearly just say, well, probability of male, it's simple, it's 115 divided by 200. The probability of the ant, and that is also how I did it, was to work out the ones that feel simpler to do that first, so that you nearly eliminate the options before you need to do the longer one. Okay, so that's a few problems on the probability distribution. So nearly the introduction to probabilities. What we will do next time is that we will now go into the next set of probabilities that will look at your random variables, your discrete, your Poisson, your, what is the other one? Binomial. So we'll do that next week. I think, and I must just make sure that your second assignment, the due date's on that, but also that it normally covers study unit 4 and 5. I don't think it covers 6. I think assignment 3, 6, and 7. But we will then do nearly the same process. Study unit 5 next week. Probably study unit 5 will be split over 2 weeks, because it is a lot to get through study unit 5. And then we'll do a recap of 4 and 5 again before you need to start with your second assignment. Is there questions around probability? Is there anything that you're unclear about in the probabilities? I know for 1610 this is probably not high priority at the moment with wanting to do assignment 1 done, but for 1510 as well, hope that this will help at least when you start preparing for your second assignment. But please, again, if you're not on the WhatsApp group, please send me a WhatsApp. I want to send some summary documents that I have created. I just want to send that through tomorrow nearly, so that you at least have my summary documents, that you can use it while you're also preparing for the chapters. Okay, that was been a bit earlier tonight, but Hopefully from next week, we'll make it from 6 o'clock. Um, I'm hopefully on a different load shedding schedule next week. So we'll do next week 6 to 8 instead of a 5 o'clock session. I know the 5 o'clock is a difficult time slot for people to join. So next week we'll definitely move this on with an hour so that it is six to eight. But I'll also communicate that um, through Unisa. We'll send out that invites. But next week again, we will be hopefully back to 6 to 8 time slot. Okay, if there's not any questions, that is it for tonight. So if anybody wants to ask something, please do. Else we'll see again next week.
Thanks, Sean.
Cool. Thanks, guys. Hope it at least helps you um, with the preparing and those kind of things.